Hi everybody, and good afternoon. Today we're going to be talking all about FTA, the fundamental theorem of algebra, and then its corollary. And we're going to use that to write polynomial equations with the given roots. So just to remind you guys, this is something we talked about in the quadratic section, which also applies in polynomials. There are other names for a root. Remember, roots are your solutions, which are your x-intercepts, which are also called your zeros because that's when your y value is 0, right? And then if you are trying to write the simplest polynomial with the roots -1, then 2/3, and then the number 4, we actually did this in Algebra 2 in chapter whatever it was, quadratics, so 5. So if we have a root which is -1, that means that your original function had a factor that was a positive one. Remember, they're opposites. For 2/3, right, if you're thinking about it, I would have to add the 2 to the other side and then divide by 3, and the opposite of that would be 3x minus 2. A lot of you would want to write something like x minus 2/3. This is okay, but then you have to multiply with fractions and there's a lot of room for error there. So what I would like you to do this time is to think about how to work your way backwards to get 2/3, right? I would add 2 to the other side and then divide by 3, so I must have 3x minus 2 as my factor. And then this last one, if my answer is a positive 4, my factor must be -4. So then, in order to write your simplest polynomial, what you're going to have to do is FOIL. Combine like terms to get 3x squared plus x minus 2, and then you still have to multiply x minus 4. And then you're going to have to distribute your x to get 3x cubed plus x squared minus 2x minus 12x squared minus 4x, and then plus 8. And then we can combine like terms. So I get 3x cubed minus 11x squared. And then we have our x's, and it looks like minus 6x, and then a plus 8. This is my simplest polynomial with these roots, right? And then there is this next type of example. If they ever give you a 0 where you have some sort of conjugate, so it could either be an I or you could see something like 2 plus root 3. Every time you see something irrational like a complex number, you always need its conjugate. So remember, that's where you have the opposite sign of that complex piece or that irrational piece, right? So once again, if we had root 3, it would become 2 minus root 3 or something. So you need, every time you see something that's complex, you need to add on its conjugate, and then we can start multiplying this stuff out. So we have our factors, right? We have y is equal to, in this case, we have x minus 2 plus I. And then we have x minus 2 minus I. And then we have x minus, and then 1. And what we're going to do, and if you're using the notes that I posted, you might want to just use a separate sheet of paper for this when we distribute. So I'm just going to write C page 2. And then you're going to see we can do some fun stuff with these conjugates. Please always multiply your conjugates first. So once again, this is example 2. You need to multiply your complex conjugates first. So when you do that, I like to use the box method. I have x And then if I were to distribute this minus sign, I have x minus 2 minus I. And then this next side, if I were to distribute the negative, let me zoom out a little bit. If I were to distribute the negative here, I'd get x minus 2 and then a plus I. And when I multiply, I'm using that box method this time, I get x squared minus 2x minus ix, and then minus 2x plus 4 minus 2I, and then I get plus xi minus 2I. Oh, whoops, I did something wrong. Look, negative I times negative 2 is a positive 2I. So fix that for me. And then finally, negative I times a positive I is negative I squared, which gives me a positive 1. So think about it, I get negative 1. I squared is negative 1, but the negative on the outside makes it a positive 1. So I need to start combining like terms, but what you're going to notice is a positive xi and a negative x and I will cancel. A negative 2i and a positive 2i cancel. And we can start combining our like terms to get x squared minus 4x, and then it looks like plus 5. And then we can multiply it by that last factor, x minus 1. And then we should get our final answer after we distribute and combine like terms. So once again, we got to combine our like terms and get our final answer, which is x cubed minus 5x squared plus 9x minus 5. Beautiful. Sorry, I forgot my face was in the corner covering that up. Let me know if you have any questions on that. Email me. All right. The next big concept is called the fundamental theorem of algebra. So according to the FTA, this says that the number of possible solutions is equal to the degree. Every time. So if our degree is 4, in this case by FTA, there are 4 possible solutions, right? Now, I haven't taught you guys how to factor something that is 5 terms. So what we're going to do is just use the rational root theorem to come up with, rational root theorem to come up with the possible solutions, right? These are the possible rational solutions. So remember, you need to know what your p is, which is your constant, so negative 36. And then you need to know what your q is, which is a positive 1. So the factors of 1 are plus or minus 1. And the factors of 36, well, if I were to list those, that would be plus or minus 1, 2, 3, 4, 6, 9. Lots of them, right? 12, 18, and 36. So all of those would get a plus or minus. And remember, we're looking at the ratio of p's divided by q's. So since we only have one option for q, it's just going to be all of these options, but just plus or minus. And those are all of our possible roots. And we can do the same thing here with this next one. But once again, we need to know what our p's and our q's are. In this case, q is 1, so we're only going to have to divide by plus or minus 1. So our answers are actually just going to be the factors of negative 20, which are plus or minus 1, plus or minus 2, 4, 5, 10, and 20. So then, once again, since you're only dividing by positive or negative 1, you're just left with these solutions, right? Okay, last but not least, we're going to have to use the irrational root theorem with this one. It says write the simplest function with the zeros 2i and 3. Whenever you have something that is complex, so either irrational or imaginary, you need its conjugate, which means that complex piece needs to change signs. So when you're writing your polynomial, you're going to have to do x minus 2i, and then an x plus 2i, and then an x minus 3. So the very first thing you need to do is multiply out x minus 2i and x plus 2i. And when you do that, you're going to get x squared plus 2ix minus 2ix, and then minus 4i squared. Remember, I squared is -1. -1 times -4 is a positive 4. Your 2ix and -2ix cancel, so you're left with x squared plus 4. And then the last step that you have to do is multiply that by x minus 3. And then when you FOIL that out, you should be getting x cubed minus 3x squared plus 4x minus 12. Alrighty. And if you all have any questions, like I said, just let me know. Give me an email. Good luck.